Hello, I'm Stéphane Graber. I'm the project leader for LXD, and for this last video of 2021, I figured we'd do something a bit different and actually look forward at LXD 5.0 LTS and just what's going to be in there, and also bring in a couple of the team members to go through some of those items. The first thing I want to do is actually go through what the LXD team looks like these days, because we had a video at some point, was it earlier this year or late last year, something like that, which had the entire team present and kind of talking about what they're doing. But the team grew significantly this year. We're actually somewhere around 10 people now. So I figured I would go through everyone on the team and just kind of what they're doing, mostly for excellent. If you see their name on the forum or on GitHub or something, you can figure out who they are. So Christian Brauner has been around quite a while at Canonical, and has been working these days primarily on our Linux kernel development. So implementing things like VFS ID map shifting and a whole bunch of other BDevDs and a whole bunch of other features that we've been using for containers for a little while now. The next is Eric Jolina, who started with us in July, is the engineering director for everything LXD at Canonical. Then we've got a couple of new engineers on LXD proper, so that's Mark Lang and Max Asner, who are both software engineers working on LXD itself, primarily around clustering and scalability. Then we've got Mathieu Baudret, who's the maintainer for DQLite, so the distributed database that we use to run LXD, especially inside clusters. So he's working full-time on that. We also have a product manager who started just a couple of weeks ago, Miona Alexic, who's helping with a lot of the content and artifacts and stuff that we need internally as for LXD as a product, effectively. We also have Ruth Fuchs, who's joined us in August, and who's the technical writer for LXD. So she's been she's been helping us a lot with reworking some of the content, some of the tooling around documentation, finding gaps, looking at how we can improve documentation and content and structure kind of in the future. The main stuff that you might have seen her do so far has been changes to our website. We updated a bunch of pages, changed structure, added more graphics, a bunch of other things to really make it easier for people to get started with LXD. Then we've got Simon, so Simon Daziel, who's a software engineer as well on the LXD team, but is focusing on maintaining the LXD charm. So we've got a Juju charm that can deploy LXD, including clusters, including Ceph and Oven, and a whole bunch of other things. So he's been working full time on that, and still has quite a lot. We can do that to really automate LXD deployments. Then you've got myself. So at Canonical, I'm the engineering manager for LXD, also the project leader for LXD, LXC, and a whole bunch of other things on the community side. Then we've got Thomas Hipp, who's been around with us for quite a while. He's one of the engineers on LXD proper as well, and is the maintainer for Distro Builder that we use to build all of the distribution images, both containers and virtual machines for LXD. And lastly, we've got Tom Parrott, who's also been around with us for quite a while as a senior engineer on the LXD team and works primarily on everything LXD itself. So whether it's like storage, network, clustering, anything really on LXD itself. And also should definitely mention the 45 plus people who've contributed to LXD in 2021. So it was also always great to see community members contributing there. And that ranges from a few people who just did like a one-time drive-by documentation fix or tiny typo fix or small bug fix, or that kind of stuff, all the way to community members who've contributed dozens of features at this point this year. So it's really great. We're hoping to see a lot more of that going on, and we love it. Then on to just kind of put LXD 5.0 in context. So as a reminder, LXD has two main type of releases. We've got LTS releases. Those get released every 2 years. They are supported for a duration of 5 years. They get bug fix and security updates for the first 2 years. There's no fixed schedule as to when we publish those bug fixes, but we tend to do them every 3 to 6 months effectively. So that happens for the first 2 years where we actively backport every single bug fix effectively. After that, so as soon as the next LTS releases, the previous LTS goes into security only, which right now means for LXD, LXD 2.0 LTS is end of life. LXD 3.0 LTS is security only. LXD 4.0 LTS is security and bug fix. And the release cycle is aligned with Ubuntu LTS releases, so it's every 2 years and usually happens end of March, early April, so that it's included inside of the Ubuntu LTS that releases end of April. Then we've got feature releases, so those are released monthly, and they're only supported until the next one comes out. That's where you get all of the new shiny features, because like we land those upstream in our main repo and they get into the next monthly release. We do a few select bug fixes as cherry picks inside of some of the packages, especially if you're using the LXD snap, then you're gonna get a bunch of cherry picks that we feel are important to get and that can't really wait until next month. But we don't do point releases or like new tarbos or that kind of stuff for those releases. The idea is to really keep them very lightweight so we can release one in an afternoon, all testing included. And that's effectively it for some of the introduction content. Like that's what the team looks like. That's what our release cycle looks like. That's kind of where we are. LXD 5.0 is lined up with Ubuntu 20.04 LTS, which is going to be releasing end of April 2022. So on our side, we're expecting a late March to early April release of LXD 5.0, so that there's a bit of time in between that and the actual Ubuntu release, so that we can make sure everything all looks good. And I'm gonna be bringing in now my two guests. So I've got Tom Parrott and Christian Brauner. They're both senior engineers on the LXD team. They've been at Canonical for quite a few years at this point. And we're gonna be going together through the main features and the main things where you're gonna be getting with LXD 5.0 LTS. So we're gonna be starting with general features. I'm actually trying to remember who's going through what. Yeah, I lost that email. I think I'm doing file transfer and P2C, P2A, right? Okay, so I'm gonna be starting with those. We're gonna have a completely new file transfer API in LXD, which is quite exciting because our current file transfer API is nice and kind of RESTful. It's easy to pull file, push files. It's nice. The problem is that every single file we transfer that way causes a sub-process to be spawned and attached to the container or to the virtual machine. And if you're doing a batch of files like recursive transfers or you need to access a lot of data, it's really slow and it's really resource intensive. So we're working to change that server side to effectively have a process that can linger for like up to 10 seconds or something inside of the instance that can process multiple queries. So both to accelerate our existing API, but also to enable a new WebSocket-based API that allows for like multiple streams of requests going through it. That should make some tools like Ansible that uses our file transfer API quite extensively significantly faster. And it will also allow, our end goal, and we really hope we're going to get to it for 5.0, we'll say, is to implement a Fuse client for LXD instances. So that even if your instance is running in the cloud or on some other hardware far away from you, you can do LXD file mount the instance and the path you want inside that instance and a directory on your system, and it's going to mount the file system of the instance on the directory using that new file transfer API. So that will be really exciting. If that all works, we think we can get it working on at least clients running on Linux, and it looks like macOS as well. Windows doesn't have a Fuse implementation, so we can't do it there, but you could do it in WSL on Windows. So that's quite exciting. We're reworking the migration tool. So we've got LXD P2C right now that will take a system and dump it into a container effectively. We're now extending that to be a bit more, support more authentication methods, to support projects, to be more interactive, and also to support moving into virtual machines so that you can pass a physical disk or partition or an existing VM file and then stream that into a new virtual machine. So that's for those two. Christian, you want to go over the Cisco interception?
Yeah, sure. So as many of you might know, LXD defaults to running unprivileged containers. So extended syscall interception is a feature that is, for now at least, specific to containers. And in unprivileged containers, a range of operation that are exposed via system calls will not be permitted and usually will fail. So system call operations that are not allowed in unprivileged containers that include, for example, the creation of character and block device nodes, or the mounting of block-backed file systems such as X4 or XFS. And such systems calls will often also fail when LXD can guarantee that performing this system call in this specific instance is safe. So, for example, mounting an X4 or XFS file system or exposing a device to the container will not work, even if the device or the file system in question has been specifically dedicated to the container and is known to not corrupt or attack the system in any way. So in order to allow LXD to grant such exceptions where a system call can safely succeed, we have done work some time ago, actually, together with other people, to add system call interception to the kernel. And system call interception allows LXD to intercept system calls coming from processes running inside unprivileged containers. And essentially, this allows LXD to emulate the relevant operation that is exposed via this system call for the container. And in this way, LXD can currently already transparently mount specific file systems that an administrator for a LXD instance has allowed for a given container, or create device nodes that are known to be safe. And in LXD 5.0, we want to allow the interception of certain classes of scheduler system calls. For example, a SCED set scheduler, hard word that's hard to pronounce, or possibly a SCED set adder. And this will allow certain workloads that require to change their scheduler settings to run unimpeded in unprivileged containers. So instead of failing to change the scheduling options and thereby maybe even failing to run in unprivileged containers altogether, such tasks can have their scheduler system calls handled by LXD. And of course, similar to other system call interception features, an administrator with privileges on the system will be required to allow for this feature to be used, because as always, we are taking security seriously. And I think next one up is Tom.
Well, actually, so there was, on that one, there was another system call also have on the list for this cycle, which is sysinfo.
Oh, sysinfo.
Yeah. So for sysinfo, it's because we've got LXCFS right now, which exposes, well, like proc files and some sys files based on the limits applied to the containers. That works pretty well. The problem is that there are other ways to figure out how much memory you have or CPUs and that kind of stuff, and that's through a system call. And right now, the few programs that do that get the host information and might get confused. So we want to intercept sysinfo and effectively fill that information struct with what we know from C groups and XCFS effectively. All right, and now on to Tom for the other 2 points here.
Yeah, so Cloud Init, the upstream project, has added native support for LXD as a data source now, using the dev LXD device inside containers. And so previously, the Cloud Init support in LXD was using sort of overloaded user custom keys, so user dot, and that was a bit of a strange place to be putting the Cloud Init config, because those keys are sort of user definable. So LXD now that the upstream Cloud Init has first class support for LXD as a data source, we've mirrored that in LXD 4.21, and we have now the first class Cloud Init config keys for an instance. So that avoids us having to use previously, the way we did it was we used template config files and injected those into the container, which we don't need to do anymore. I think that about covers it. Does it, Stéphane?
Yep.
And then degraded startup is the next item for LXD 5.0. There's two aspects to that. The first is storage pools. So somewhat common scenario you can get yourself into is if you have a storage pool set up on LXD and then you shut LXD down and remove the backing storage pool using an external tool like zpool remove or zpool destroy or something like that, then when you come to start LXD up again, it will try and activate and mount that storage pool, and it will fail because the pool doesn't actually exist anymore. And so currently LXD will fail to start up, and you'll have to manually either modify the database to tell LXD that the storage pool doesn't exist anymore, or you have to restore some semblance of backing storage pool so that LXD can start up again. So our plan with this is to basically make LXD start up even if a storage pool is missing, but heavily log an error that the storage pool doesn't exist, and obviously prevent trying to start any instances or custom volumes that LXD believes should be on that storage pool. And that will allow you then to use the command line tools to remove the storage pool or potentially edit its config to point it to a different backing storage pool, which would then allow you to recover the operation of the full operation of LXD. And the important thing is that other instances and custom volumes on other storage pools that are unaffected will continue to operate normally. The second part of degraded startup is similarly related, is networking. Today it's not so bad as storage pools. If you are missing a network, say you've got a bridge network set up that's using a external parent interface, and that parent interface isn't there when LXD starts, LXD will just notice that, skip over it, and that it won't try and configure it again. You'll have to manually reload LXD for it to try and set up that interface again. So we are adding the ability for LXD to monitor for networks being available if they aren't started successfully on LXD startup, and when they do become available, we'll be able to then start up the network and configure it as normal.
Yeah, it's going to be quite. I mean, that's a pretty big source of support requests right now. Is people having LXD being able to start for one of those reasons. Yeah, storage especially. So that would be quite useful because people add temporary storage pools and they forget about them, and then when they reboot the system, the Z pool or whatever is gone, and LXD won't start up anymore. So that's going to be quite useful. I think you also got a Discord plug.
Yep, I can cover that. So we added probably 2 or 3 releases ago now in LXD the ability to hot plug network interface cards into VMs. So that effectively we pre-reserve several slots on the PCI bus for network cards, and then you can add new network cards without rebooting the virtual machine, and they will appear as hot plug devices inside the virtual machine. For LXD 5.0, we want to do the same thing for disks, so you can attach additional disk devices, with the exception, obviously, not the root device, but additional external disk devices or custom volumes. We would be able to hot plug them into LXD and then show up as block devices inside the virtual machine without rebooting the virtual machine first.
All right. I think I'm doing the next few ones. So for the other thing we're looking at doing for the virtual machine stuff is, and we actually already have that one. It's going to be in 4.22. Is the agentless VM metrics. So right now you get accurate network information and storage, number of processes, and a whole bunch of other things for VMs, just like you do for containers. But that's all reliant on the agent running inside of the VM and feeding us the right data. The issue there is if you're running effectively untrusted workloads, or you're running operating systems where the agent cannot run, then you don't have that information, or you might have incorrect, spoofed type information. So we've got a new configuration option which can control that behavior and effectively say that we do not trust the agent. The only thing that the agent will be allowed to do is exec sessions and file transfer sessions, but we don't get any of the usage data from it. Instead, we rely on what the host knows. The host, unfortunately, doesn't know much. So you've got just a rough CPU usage information. The memory will most likely, in many cases, will just show the maximum usage for the VM, because QEMU doesn't necessarily know exactly how much has been freed or what's the state of things there. And similarly for storage, we can't report the actual file system usage. Instead, we need to report the block device usage. And on most file systems, on most storage backends, that just means the entire block size, and just being like, no idea, it might be full, it might not be, we don't know. But that does mean you can run virtual machines in less trusted environments by not effectively having the user be able to feed you bad data. And I'm also going to be covering the desktop integration bits. So, well, at least some of them. For desktop, so one thing we want to do is really to make it easier to integrate LXD by default, especially on Linux desktops. And for that to be the case, we feel that LXD should just work. You shouldn't have to need to put the user in the right group and then run LXD in it and configure network and storage and all of that stuff, because that's a few extra steps. And also it means that you can only do it through privileged users, like only those that could have root on your system would be allowed to use LXD, which is a bit unfortunate. So what we're doing is preparing a separate daemon proxy type thing, effectively, that on the desktop, so you'd get an Ubuntu desktop or whatever the distro desktop with LXD pre-installed. And as a user, you'll be able to just immediately run LXDlist, LXDlaunch, it just interact with LXD and it will just work out of the box. And what happens behind the scenes is that the first time a user on the system tries to interact with LXD, we've got an intermediate daemon that will figure out who the user is, figure out that that user never talked to LXD before, will generate credentials for that user, will notice that LXD has never been initialized, will initialize LXD with some default networking and storage options, will create a project for that user, will restrict that project so that the user cannot run privileged containers, can't access hardware directly, can't do anything that would allow privilege escalation to root effectively. And we'll also put in place the restricted bind mounts and UID, GID stuff that Tom can quickly talk about after. So we've putting together a pretty comprehensive project for that user. We'll initialize the default profile within that project, and the user will just be interacting with that and won't really know that they're restricted unless they're trying to run like a privileged container or pass some restricted device or create other projects. So that should really make for like a very seamless out-of-the-box experience. And then those users that you trust with more access, those can still be put in the LXD group and get full access to LXD and all features. Or the administrator can tweak the user's projects to have more features. The nice way with all of that happening effectively on demand, so on first connection of a user, everything gets created, means that it even works on corporate systems that are using centralized authentication, because those systems can potentially have 50 different users that kind of use the same machine at some point. And you don't need to pre-create anything. It doesn't look at the local users or anything. It just, first time a given UID talks to LXD, we pre-set up things. And there will be a control group that's used for that, so you can make it so that only users within a specific group get that feature, and everyone else will just be rejected. So that's pretty much it for that one. I think Tom can cover kind of two of the bits in there, which were like the restricted bind mounts and restricted UID, GID that we needed for this.
Yes. So as Stéphane said, the LXD, each unprivileged user will have their own project, and that will be a restricted project, which means by default in LXD today, you won't be able to add any external bind mounts into your containers or virtual machines. And one of the obviously useful things for running sort of development containers for your user is to be able to pass in their sort of directories that they own, so home directory or project directories and that sort of things into their instances. So we've added a feature. This is also in LXD 4.21 called restricted bind mounts, and it gives the administrator of the project, so the person creating the restricted project, the ability to define one or more source path prefixes that disks can be added to, or can use paths underneath those prefixes. For example, I might add home user Tom as a restricted bind mount path, and then I can create directories under that and pass any of those directories into my instances or in my entire home directory if I want to. One thing we had to consider with that from a security perspective is that because LXD is still running as root behind the scenes, it is perfectly possible to create a symlink that matches the prefix path that you're allowed to use, but actually points somewhere else on the system that you're not allowed to access. And you could even try and race LXD by initially, creating a symlink that points to somewhere you are allowed to use, and then at the last minute change that to somewhere you're not allowed to use. So we had to be careful when setting this up so that we don't sort of seemingly think that the path is allowed, and then behind the scenes somebody changes it at the last minute so that it points to a path that isn't allowed. So in order to do that, we're using the open at2 syscall to atomically resolve symlinks, and then passing that bind mount using a file descriptor so that it cannot change after it's been opened. And we are sure that it's been checked by the kernel that it is in fact resolving to a path beneath or at the allowed path that the administrator has specified. So that allows us to get bind mounts into the containers and virtual machines safely. The next problem is that normally we would use something like shiftfs or ID mapped ID map mounts to allow the container or the virtual machine to access the disk share that's been passed in using the actual user IDs that are on the system. However, we don't want the ability for somebody to create a file that is owned by root in the container or the virtual machine, and then have the sticky bit set, the set UID bit set that would allow you to, on the outside of the instance, then run that as the genuine root user on the system. But that would be a security problem. So we don't allow shift FS or ID mapped mounts to work when you're using restricted bind mounts, and instead we've introduced the ability to specify particular UIDs and GIDs that can be individually mapped either as individual IDs or ranges for an instance, and that functionality already exists for containers and virtual machines. But what we've done is we've now restricted what IDs can be mapped at a project level using the restricted UID and GID settings. So those sort of three things, or those two things together, allow safely passing in disk directory shares into instances when you're an unprivileged user.
Yeah, and that extra proxy thing I'm currently writing will effectively configure that automatically. So like whenever a new project is created, you will automatically be allowed to use your own UID and GID, and you'll be allowed to use your own home directory automatically. And then if you want anything else, then your administrator can update the project settings to allow that. So that's going to be quite exciting. I think we're now on the home stretch of getting that done. Hopefully LXD 4.22 will effectively ship with that. That would be quite neat. All right, and now on to clustering, and I kind of mixed it like clustering and large deployments, because some of those features also are not really cluster specific, but are mostly used by those that tend to run larger deployments and clusters effectively. I think it's back to Tom for the first two.
Yeah. So cluster server grouping is the ability to define groups of cluster members within your overall cluster. So sticking with the theme of larger deployments, you may have inside your cluster several different cluster members that are different hardware or different performance characteristics, more CPU, more RAM, something like that, better disk IO. And you might want to, when you're launching instances, be able to target those groups for your instance. You can already do that today to a certain extent, but you can actually specify the particular cluster member that an instance will be deployed against. But this new feature allows you to say, well, I want to deploy my instance on any cluster member that is in this group. And the other ability you can do is to say that from a scheduling perspective, that you require servers in this group to be targeted explicitly by group or member name. And if there isn't a particular target when launching an instance, then these servers won't be included for new instances. I think that about covers it.
Yeah, did you cover the part where we can actually restrict projects to specific groups as well?
I didn't know.
Yeah, so that's the other thing. Like, it's possible for a restricted project to also be limited to some specific groups. So if you can totally have like a whole bunch of hardware, and then only want to use a subset, like potentially older systems or something, that you give more free access to some specific projects. So you can restrict those projects to those specific groups, and they'll only be able to use machines from there.
And so the next item is the cluster performance, which is event distribution. That's something I'm looking into at the moment. So at the current stage, when you've got a LXD cluster, all the members in a LXD cluster will open a connection with every other member in the cluster to collect events that are occurring on that cluster member. So it's a so-called full mesh. This becomes a bit of a problem when you scale out the cluster and grow the cluster, because you've got a lot of connections open between every member and every other member, and every event is being distributed across all members and causing sort of additional go routines to be needed to be run continuously in the background and triggering interrupts as every event is received. So what we're looking to do is add the concept of a event hub role, which you can assign to 2 or more cluster members, and that will allow you to specify which cluster members will take on the event hub role, which means in that case, all other cluster members that aren't event hubs will only connect to the event hub members. They won't connect to every other member in the cluster. And then it's up to the event hubs to distribute messages to every member that is connected to it and any other event hub. And we will need to make sure that we're not creating message loops by messages that are received from one event hub being forwarded on to another, in a loop. So this will reduce the number of connections that a standard cluster member will have, because you might only have 2 event hub members, and so every cluster member will now only have to connect to 2 event hubs and not have to connect to every other member. So it should make things a little bit easier on the systems.
Yeah, it also makes kind of debugging and tracking things a bit easier, because if you get a large enough cluster, you can assign those 2 roles to machines that are currently not acting as database voters or database leaders, or even database standbys. And that means that you can then easily figure out if you're seeing a big amount of traffic towards those that are part of the database, you're gonna know for sure that this is effectively database traffic. And if you see a big spike of CPU or network load on those that have the event hub role, then you know that it's something related to internal events that's causing the load. So that makes debugging quite a bit easier as well. I think the next few ones are mine. So Trust Store certificate self-renewal is a feature we've landed already. It's in, I think, 421. Yeah, 421. And this allows a user, an administrator can now edit through LXD config trust edit any certificate and replace the certificate itself with something else without having to delete it and add it back. The other thing that this allows is for a restricted user, so one who's using a certificate that's restricted to just a number of projects. Those users are not global admins, so they can't normally add a new certificate into the Trust Store, but now they're allowed to modify their own certificate, like as in update just the certificate itself to a newer one. The reason for that is that we've got some downstream users, things like MAS, that interact with our API, that can be restricted, and that have certificates that are only valid for a few months to a year. And they need a way to update those as they get close to the expiry. So that's the reason for that. That's been working pretty well. The other thing we're looking at doing soon is token-based remote connection. So still related to the Trust Store. Right now, your only options to add yourself to the Trust Store is either connect by knowing the trust password, so knowing that one global password that's set on LXD, which we're trying to get rid of as much as possible, or generate your client certificate, so let the LXD client generate it, and then transfer that certificate to the server or to a machine that's already trusted by the server, and then do LXD config trust add on the certificate itself to add it to the trust store. So that's currently the two methods. What we want to do is something very similar to what we've done for clustering recently. With clusters, you can do LXD cluster add, and that gets you a token. So it's like a chunk of base64. And you can then give that to a joining server, and that gives them effectively a one-time password to log in, or to add themselves. And that also restricts them to a particular name, and that gives them all of the potential addresses that they might need to reach to connect to that LXD deployment. So we want to do the same thing with the trust store, so that it's possible to create an entry in the trust store without a certificate yet, effectively. That will be listed as like pending or something along those lines. That gives you a token, and then you can do LXD remote add some name, the token, and that will just that will contain enough of the certificate to validate it, so it won't cause a prompt to validate the fingerprint of the certificate. That contains information needed to find LXD, so that you don't need to enter the URL or anything. And that includes the one-time passwords that allows for that client certificate to be added to the trust store on the LXD side. So that should, with that feature, we pretty much won't have any more reason for anyone to ever use the trust password in general. So we'll be able to very strongly recommend against ever setting it. And the other two pieces, I think I'll tell mine. So one of them is I've added network zone support last cycle. That makes it possible to get forward and reverse DNS records for your LXD instances. What it doesn't currently allow is for anything else. So the plan there is to actually make it possible for you to manually add records to a zone. So whether they're straightforward A or quad A's or PTR records, or more complex records like CNAMEs, SRV, or text records, that will be possible directly through the LXD API, and actually will make it more feasible to give a good chunk of your DNS effectively to LXD, because you'll be able to still add other records. The main thing there is that it will make it much easier for those who need to issue certificates for like Let's Encrypt, and who are using DNS-based authentication to just generate those temporary records, or same thing if you're using, I guess Google, Microsoft, and a bunch of other services. If you use those and you need to prove that you own a given domain, they pretty much always ask that you add a temporary TXT record or something along those lines. So that will make it possible to do that kind of stuff. The last feature there is per network oven logs. So right now, if you set ACLs on an oven network in LXD, you can choose to log any failures, or I think even any success. You get to choose what you want there. The problem is that this lands into a host-specific log file that only the administrator can get, and they need to go get it over SSH effectively. So the idea there is that we want to see, well, it's not clear what the implementation will be, but the end user result will be that you'll be able to pull the logs for a given network, and that will include some amount of firewall logging effectively. So we're not going to be keeping, we don't want a DOS to be possible. We don't want the user to be able to just fill the disk. So it's going to be a limited quantity of log entries, but you'll be able to pull those and figure out why is something getting denied or even accepted, depending on what your rules are looking like. And that's it for the clustering stuff. Then on to Christian, who's going to be talking mostly about ID mapped mounts and a bit about core scheduling.
Yeah, okay. We always have multiple things going on. Technically, you could also include bin format MISC, I guess, and stuff like that. So we're also very active in kernel development. This has been that way for a long time with LXD, because we interact with the kernel on so many levels in LXD that it's kind of unavoidable that we run into issues that we then want to or need to fix, or need extensions to actually make a use case work better for us. So part of that work was ID map mounts. Tom referenced this earlier already. For a long time, we ran into the issue that when you run unprivileged containers and you use user namespaces, which is what unprivileged containers are, then the container runs with a UID and GID mapping to isolate the UIDs and GIDs associated with the container from the rest of the system. And the problem is obviously that this also has effects on the file system interactions that such a container can have. It's not possible to easily interact with files that are owned in the regular UID and GID range that you would expect on a regular host. And so this obviously requires you to recursively chown every time you start a container, every time you create a container for the first time, or you change the UID and GID mapping for the container to the relevant UIDs and GIDs. So for example, you have to change the ownership of the whole rootfs when you create a new container. And that's not just prohibitively costly, it can also go wrong. You can fail in the middle, and then half of your files have been chowned and the other half hasn't been chowned, and it's difficult to recover from that kind of situation. And obviously, if you have very large containers or data containers even, or some storage devices, then recursively choning them is just sometimes can take like hours or longer even. And one of the solutions that we originally came up with was called ShiftFS, which was a tiny file system that took care that the ownership of a given file system matches the ownership of the UIDs and GIDs inside of the container. But that has proven kind of difficult, and it's not very flexible because it's only applicable to a whole file system. So for example, you cannot just add a specific directory into the container that has a different UID and GID mapping than another directory that you add to the container. There's a lot of inflexibility there, which is why we came up with a very different solution for upstream, which is called IDMap mounts, which essentially just allows you to change ownership to match the container's user namespace on a per mount basis. And this requires general VFS work, which is the final system abstraction in the kernel, but it also requires work in specific file systems. And so far, what we have supported is XFS, X4, and Btrfs. These are file systems that LXD actively uses. But LXD obviously also makes use of Ceph. It's a highly reliable distributed file system. And in the cloud, this is like a really big use case for us. And so we want to add support for IDMap mounts to CephFS. Patches for this already exist. We want to push for this upstream for the 5.0 development cycle, and are already in the process of doing so. And Canonical and Ubuntu is making use of ZFS quite heavily. It's also a file system that LXD supports. And so we want to add support for IDMap mounts to ZFS as well. And once all of these file systems, these remaining two file systems, in this case ZFS and CephFS, have been converted, we can get rid of the old ShiftFS implementation that we have carried for a long time. So we're reducing technical depth and also creating new features. And another use case is that a privileged mount. So another thing that we want to work on is making it possible to create unprivileged IDMap mounts. So currently, in order to create IDMap mounts, you need to be CAPSYS admin capable on the system. So you need to be a very privileged user, is what I'm saying. And obviously, we also support the use case where people run containers within LXD containers. So for example, some people create unprivileged LXD containers to run privileged Docker containers, because usually Docker containers don't run with UID and GID mapping, so are less safe. And LXD provides an additional safety layer. And obviously, we want to enable all container runtimes to make use of IDMap mounts to get around the issues associated with having to recursively change ownership. And so it would be nice if we also had a way to let such container managers that run inside of LXD containers create IDMap mounts without requiring privileges on the host. There are different ways how we can do this. Either we can really make this a pure kernel level feature where we come up with a safe delegation mechanism in the kernel, or we enable it via syscall interception so that LXD can intercept such calls and create the ID map mounts for the workload itself. That's the exact implementation is still up for debate. And last but not least, over the last couple of years, I don't know if you guys realized it, there was a lot of issues with in software and hardware security, specifically with Spectre and Meltdown. And we had to mitigate this in the upstream kernel in various ways. A lot of smart people spent a lot of brain power in there. And one of the solutions that came out of this is a core scheduling. So essentially the threat model that we currently still face is that hyperthreads can attack each other that share, because they share too much information essentially. And in core scheduling is the idea that you create domains of tasks that can be scheduled together, which are separated from other tasks that can be scheduled together. So that these cannot interact negatively with each other and affect each other. And LXD has support for this for virtual machines and for containers alike, but the API that we currently have to use is suboptimal, as it requires us to do essentially fork off a lot of helper processes to allocate core scheduling domains and so on. It's not just costly, there is also essentially tiny races where the newly created task runs outside of the targeted core scheduling domain. And so we added a new API, or are in the process of adding a new API that will allow you to set the core scheduling domain for another task from another task, which currently isn't as easy. And there are various other things we are working on. One thing Stéphane hasn't mentioned here is that we also will make it possible to use bin format, different bin format handlers inside of a container and outside of a container. So for example, when you want to execute S390X binaries inside of your container, you can use QEMUser static. And to make this work magically without actually having to invoke the relevant S390X or ARM64 binary manually by invoking QEMUser static, you can register these binaries in a so-called bin format MISC instance, and then it will automatically just work. The kernel will directly use this handler to execute these binaries. You don't have to differentiate between S390X binaries and, for example, regular x86-64 binaries. And that's it from the kernel side for 5.0 so far.
Yeah, thanks, Christian. Yeah, we've got quite a lot of moving pieces there. Plus, I mean, outside of what we've got listed on those, we also fixed a lot of other bugs. We've got a bunch of other work around optimization, whether it's like storage or network or clustering. We've been doing a lot of cleanup. It's an LTS. We need to maintain it and deal with it for 5 years. So we're trying to really clean things up. I guess one thing I can also mention is that we've been reworking our minimal releases, our dependencies ahead of LXD 5.0. So we're going to be looking at probably, I guess, Go 117 probably what we'll require for 5.0. Right now we moved it to Go 116 ahead of 422. We've also upgraded the minimum LXD version from 3.0 to 4.0, and we're gonna QEMU will probably be requiring QEMU 6.2 or something along those lines by that point. And for the kernel, we used to be fine with anything with like 3.13 or higher, which, you know, all of those things technically might still work on older releases, but what we're willing to test and support is a different matter. For the kernel, we moved it to 5.4 currently. Which also should be pretty reasonable because it's an upstream LTS release. It's been around for a couple of years. Most distros should have that or have backported enough of it that things should be working. So we've tightened that a bit ahead of 5.0. Also, we expect that 5.0, unlike previous LTSs, will not be completely backward compatible all the way. So right now, you could technically take LXD 0.1 and upgrade it to LXD 421, and all of the database updates and everything will apply, and you'll get a working LXD. Doing that has been getting slightly costly mostly because of some of the changes around the database and that kind of stuff over the years. So we can get rid of a lot of dependencies and code if we decide that we can only upgrade from 4.0 or higher to 5.0. And we expect we'll be doing that with this release. So anyone running 2.0 and wants to move to 5.0 is going to have to jump through, or same thing with 3.0, is going to have to jump through 4.0 first. But 4.0 will still be supported for a number of years because it's an LTS, and currently does support upgrading from as far as 0.1. So not a big deal. It's just going to be a 2-stage update for anyone who's not already on 4.0 higher at the time they upgrade to 5.0. And yeah, I think that's it for all that we have today. That kind of went through what we're planning on doing for LXD 5.0. It's still quite a bit of work we need to do, especially since we're planning on having this thing out very early April, ideally late March. So there's quite a bit of work we need to finish and tidying things up. But yeah, we're quite looking forward to it. It's going to be another very solid LTS. And yeah, it's quite exciting. Anything else from you two? Any last thought?
No, this is really fun. I hope you all enjoy using LXD.
Yep, nothing from me. Thanks very much.
All right. So yeah, thanks for watching. If you've got any questions, you can leave them down in the comment section, or you can leave them on our community forum. And otherwise, this is the last video of this year, so enjoy the holidays, and I'll see you next year. Bye.